Okay guys, this is the second part and for problems on vectors. So here we have another problem. We have a force acting in this direction of 2 newtons, and we have another force acting in south 3 newtons, and this is a force that is acting in southwest direction of 5 newtons. We have to find the resultant of all these. So as we know that in vectors we have a summation rule, which is vector summation. It says that to add vectors, you have to draw the first vector. You can take any one of the vectors as your first vector, which is consider 2 newton is your first vector. Now put this second vector in such a way that its tail coincides the head of the first vector, 3 newtons. Okay, and then the third one, the same procedure, which is this one. Okay, and it makes an angle 30 degrees with the perpendicular with the y-axis. So the resultant of all these three vectors is the vector that is going from the tail of the first vector. The first vector, this is the first, this is second, this is third, to the head of the first vector, which is this one here. But this is very complicated. It's very difficult to solve all these and then some. The easy way is to first solve the first two vectors. Okay, so you will solve the first two vectors, which is this vector 2 newton and 3 newton, and we know that they are making an angle 90 degree with each other, and you find the resultant. Ignore the third one, we will use the third one later, but first of all find the find this vector first and then use that vector to to go further. Okay, so this is actually a right angle triangle. You can you know that this is hypotenuse, so this is under root this square plus this square, which is under 9 plus okay, this gives 9 plus 4 under root 13. Okay, this is only the magnitude and unit, but we don't have the direction. For direction, we, of course, vectors cannot only vectors need a direction to be fully defined. So there is a need of an angle that is required. So any angle, this angle, this angle, any angle, just we need an angle. So to find the angle, we know that consider this as our theta, because we want to know what this theta is so that we have an idea of the direction in which this resultant force is acting. Okay, we know that tan theta is equal to perpendicular divided by base, and from our previous lectures we know that the side opposite to the theta is perpendicular, so our perpendicular is 3 here, and our base is this 2 because it's holding 90 degree and it's the theta 1.5. so we will find theta for which the corresponding value is 1.5. For that, you go, if you have a calculator like this, it's better, but you can also use other calculators as well. So here we have an option that says tan inverse, right? So you press shift and then tan inverse. This is the tan inverse. So tan inverse 1.5, this gives 56.3 degrees. So this angle is actually 56.3 degrees. Now erase 3 newton and 2 newton. You have only this one, which is resultant, which is under root 3 newton, under 13 newton, and the angle is 56.3 degrees. Okay, now use this one. Now here you have to use, so this is your first vector and the second vector is this one 5 newton, and this is 30 degrees. Okay, now you can take any one as your first vector, and the other vector's edge was second vector. So all right, let's take this vector and then overlap this vector here. Okay, so let's do the overlapping. So this is your first vector, which is making 30 degrees with the y-axis, and this, then you have the second vector which is making 50, okay, 56.3 degrees. It should be somewhat like something like this. Sorry for the drawing, it's a bit TD. Okay, anyways, it should be something like this. Anyways, okay, now the vector that starts from the tail of the first vector and goes to the head of the last vector will be your resultant vector. Since in this drawing is not clear, I will have to do it another again, so that you will have a better idea of how I draw. Okay, this is the first vector, 30 degrees, and consider this is the second vector. Okay, consider this is the second vector. This is making 56.3 degrees, and this vector is the resultant vector. Now, to solve this problem where you don't have a right angle triangle, there are two ways to solve. The first way is to use everything by scale. You have to take a ruler, then you have to draw 5 newtons drawn to scale and all this, but we haven't done that. And the second method is much easier, which is the component method. The component method says they try to break these vectors into subvectors or components in x-axis and y-axis direction. Okay, for instance, this vector, I can divide this vector into subvectors, into components, I mean, in such a way that one of the vectors is along y-axis and the other vector is along x-axis. Okay, again, you can do this for the same for this one. Okay, and what you do is you sum up the corresponding components, and you sum up this one with this one and this one with this one, and then you use the Pythagoras theorem to solve things. But okay, let's go, let's see. Okay, so vector 1, vector 2, because why I'm doing this, because here the angle is not 90. Okay, if the angle is not 90, it's very difficult to solve the problems. For that, you need to subdivide the vectors into its component. Okay, and by the way, this is called rectangular. These components are rectangular components because they are making a 90 degree with each other, so they are simplifying the problem. So vector 1, you will write x component and y component. Okay, so x and y component. This is for vector 1, this is for vector 2. Okay, all right, this is vector 2 and this is vector 1. Okay, all right, this is under root 30 Newton. If this is 56.3, we have to find this one because this is 90, so this would be 90 minus 56.3. This gives 33.7 degrees. This is 33.7 degrees. Okay, now this is our angle. We will take this as our angle. So this component will be, this is because this is angle, so this is perpendicular. Okay, and the angle between this and this, this is the side that has the angle this and the right angle, so this is the base. Okay, so to find the perpendicular, we know that perpendicular is hypotenuse sine sine theta. So this angle would, this side would be P is equal to hypotenuse, which is under 13 sine 33.7 degrees. Okay, this side would be B, which is under root 13 cos 33.7 degrees. Okay, now in this triangle we have this as our angle. Okay, so this is perpendicular P, which is hypotenuse 5 sine 30 degrees. This is our base because it has right angle triangle and 30-degree angle. Why I'm repeating this? Because this has to be memorized. This rule is universal, and you have to understand this rule, that the base should be the side of the triangle is base if it has the angle and the right angle as well. Both should be on the same side. So this is the right angle, this is the angle, so this is the line. So this is base is equal to 5 cos 30 degrees. Okay, so this gives under root 13. Make sure that the degree, the angle option is in degrees. If it is in radian, it will be a mess, you know. 33.7. This gives 2.99 is almost 3. Okay, so this is 3, and this is under 13 sine 33.7. This is 2. Okay, right, this one 5 cos 30, 4.33, and this is 5 sine 30, 5 sine 30. This is okay 2.5. So let's see, this is in y-axis, so this is for vector 1. The y component is in downward direction, 3 in downward direction. Okay, okay, this is x-axis, so it's in 2 in this direction. Okay, vector 2 here. This the x-axis component is in this direction, which is 2.5 in this direction, and here it is in downward direction, so this would be 4.33 in downward direction. Now the resultant vector, okay, because they are both in this direction. Okay, so you can easily add them, you know. 2 plus 2.5 is 4.5, and the resultant will be in also in this direction. Okay, in this case this is down, this is also down, you can add both. Okay, 3, this is 7.33 is, which is also in downward direction. Remember one thing, if by coincidence, by something, one of the component was 4, for instance, for this case, and it was in this direction, and the other was 3 in this direction. Okay, now the signs are opposite, you know, because direction opposite, you don't need to add. Here you have to subtract the larger from the smaller. Okay, 4 minus 3 1, and give the direction of the larger to the resultant, because because since the magnitude for this is larger, so its effect would be greater on the resultant. So that means that assign the direction of the larger of the both to the resultant. Okay, so this is the rule. Now still we are not complete. Okay, the thing is, because we have the resultant vector, it has one component which is 4.5 in this direction, and the other component 7.33 in downward direction. So if you try to draw 4.5 in this direction, 7.33 in this direction, so our resultant would be from the first to the last. this is a resultant, and since this is a right angle triangle, you can use you have to find the magnitude, which is under root 4.5 square plus 7.33 square. This gives under root 4.5 square plus 7.33 square. This gives 8.6 Newton. We only have managed to find the magnitude. We have to find the angle as well. It's very important because angle gives the direction. Without the angle, the question is incomplete. So to find the angle, we know that the side opposite to the angle is perpendicular, and we know that tan theta is equal to perpendicular divided by base. So here is perpendicular 7.33. This is not included in this. 7.33 divided by 4.5. This gives 4.5. This gives 1.62, and we'll do again shift tan inverse 1.62. This gives 58.3 degrees. So the theta is 58.31 degrees. Now your question is complete because you have managed to find the magnitude of the resultant and the direction as well. Thank you.